Okay, so this is a smaller version of the Granddaddy problem. And so this is like the, almost like the mini Granddaddy. Okay, this is from practice exam 3. Alright, so the average cost per item to produce Q items is already given. So what we did in the Granddaddy problem is we had the total cost and we asked for the average cost. We're doing backwards. So we're multiplying by Q instead of dividing by Q. So think about it. We have the average cost, but we want the total cost. So you have to multiply by the number of items. So you're just going to multiply by Q. So you don't have to show any work for this. You just write down the correct answer. Okay. And so B, what is the minimum marginal cost, and then what is the practical interpretation of this result? Well, let's start with just finding the marginal cost, okay? I can write C prime, but I'm going to just write MC for this. I'll show you why in a second. Now, why is because to minimize a function, you take the derivative, and I just don't feel like writing C prime prime. So you could just say, you know, marginal cost has a minimum because it's a parabola, and I'm just going to pull off the vertex and not use any calculus. That's totally fine. That's fair game. But let's say you forget you could do that. So you take the derivative, set it equal to 0 because it's a calculus class, and you solve for Q. So Q is going to equal, you're going to put the minus 1.2 on the other side and get 1.2 divided by 0.06. Okay, so 1.2 divided by 0.06. You could figure this out without a calculator, but let's say you're not in the mood to. Okay, so that's 20. But that doesn't say, so B continued. Okay, so let's say Q is 20. And so now we want to know what the minimum marginal cost is. So you just chuck this in to marginal cost. And then you have 0.03 and Q squared. So Q is 20, so square it, you get 400. And then if you say minus 1.2 Q plus 13, okay, let's pull out our calculator. 0.03 times 400 minus 1.2 times 20 plus 13. You'll be shocked. Woohoo! That's evidence of it's a rigged question, because in real life things don't turn out to be 1. If it does, you should redo it because you made a mistake. Okay, so what does it mean? So have we gotten to the question, what is the minimum marginal cost? Yes. And what are the units? Is $1 per item to produce, right? To produce. And why do we care if it's production or purchasing? Well, because it says what's the practical interpretation. So that's why we care. Otherwise, we can't answer that question. So now it says what is the practical interpretation of this result? So it's like that story with the donuts, except when we were buying. You know, there are certain times in the buying process where, like, the first donut's more expensive, but you can buy them in bundles, so maybe the 7th donut is cheaper or whatever. Okay, so what this is saying is there's a certain cost of production, and when you get to this point, this is the cheapest, this is the point of cheapest production. Let's put it that way. Point of cheapest. But what do we mean by that? We don't mean cheapest average cost, but we mean the smallest marginal cost. So we're saying, like, how much more it costs to produce one item. How much it costs to make just one more. Is smallest here. Okay? Alright, so at what production level is average cost a minimum? Okay, so we already have average cost up here, so we just minimize it. And again, you can just take the vertex of that thing. You don't have to use calculus. But let's say you want to take the derivative. Go ahead and do it. So we have Q equaling 0.6 over 0.02, 0.6 over 0.02 equals 30. Wow. Looks very, very similar to the Granddaddy problem, where we had 2 and 3, and now we have 20 and 30. Okay, so it's not really that shocking, is it? Okay, so what is the lowest average cost? Ah, we only found the production level. And what is the average, lowest average cost? Okay, so what is the average lowest cost? It's A of 30. And we have to go back to A again. What is A? 0.01. It's very hard to control this. Okay, 0.01 Q squared, so that's 900, minus 0.06 times 30 plus 13. All right, so 0.01 times 900, that's because I'm being extremely lazy right now, times 30 plus 13. Did I get that right? There we go. This should equal something. There we go. That's 4, and what's average is dollars per item. Average. Just to remind ourselves, it's an average. So that's the lowest average cost is $4 per item. Right. Compute the marginal cost at Q equals 30. Well, we just did the marginal cost at 20, but we're just going to do the marginal cost at 30. Okay. And it says, how does this answer relate to the part above? You're expecting to see some kind of evidence of two parabolas crossing here. So let's just see if this works. Marginal cost, so it's going to look exactly like this line up here, except we're going to put in 30 instead of 20. 0.03 times 900 minus 1.2 times 30, and it's just going to be plus 13. And this is what I wanted. Okay. 0.03 times 900 minus 1.2 times 30 plus 13 equals. And then you should say, oh no, no, it's a different parabola. So look what happened. We had this parabola here and this parabola here, and they both ended up with $4 per item. Is that a coincidence? No, we expected this. Why? Because of your hexaflexagon. See, marginal cost equals average cost if average cost is minimized. And we minimized average cost, and we found that Q was equal to whatever it was. Q was 30. So at Q equals 30, we expect these two guys to be equal. So we have a parabola like that, and a parabola like that. Bad picture, but you see. This is supposed to be the minimum, and then it comes. So much easier to draw on a chalkboard. So this is going to be average cost is minimized. Minimum cost equals average cost. And notice minimum cost is lower than average cost, and that's what happened. See, we found minimum cost is $1 an item. Minimum marginal cost, sorry. Marginal cost is minimized at 1, but some 1 would be over here, and 4 would be over here. This must be Q is 20, and this over here must be Q is 30. There's dollars and Q's over here. Okay? So, that's not as bad as the Granddaddy problem, because I didn't, in this case, not every single concept is being tested in the same spot. But most of the concepts in the Granddaddy problem are here. Okay?